Howdy, AP PreCal. It is Miss Kosh. I am going to try and lock in, as my students would say, and make a whole bunch of videos right now. So we'll see how successful I am. On this one, this is another example. I put something like this on my review sheet. The very first problem on the review sheet is this with a different problem, and then the very last problem was optional, and it was the same idea but with a different rational function. And so I made a third example, and I'm going to work through this one to make sure we're all on the same page. So hopefully this is beneficial to you. To begin with, they're giving us the graph f of x equals 3x plus 7 over x plus 2, and they ask us to sketch it. Well, one thing that I've kind of taught, and this may be helpful but not necessary, if it helps you understand what's going on, then fantastic. If it confuses you, then skip ahead. But what I can do is I can divide this with synthetic division. I can bring down the 3. This multiplies, gives me -6. That leaves me with a 1. Okay, and then what this tells us is that I can rewrite this. So I had this f of x was equal to 3x plus 7 over x plus 2. This would be equal to 3 plus 1 over x plus 2. If I write it in this form, 1 over x plus 2 plus 3, then we can see pretty clearly that we took the parent function, y equals 1 over x, and we translated it, we moved everything left 2 and up 3, okay? So now my asymptotes are at x equals -2 and y equals +3, which is what we can also figure out by setting the denominator equal to 0 and then dividing our leading coefficients. Okay, so if I divide the leading coefficients, we have, let's see, I have an asymptote at x equals -2, y equals, and I should label that, x equals -2, and at 1, 2, 3, y equals 3, I have an asymptote, and then it says, and zeros. Okay, so the zeros happen when the numerator is equal to 0. So when I have 3x plus 7 equal to 0, I get that x is equal to when I solve that, I get x is equal to -7/3. So when x is -7/3, which is bigger than -2, then we have a 0 here. We can also check and see, so this is going to have the point -7/3 comma 0, and it's also going to have the point when I plug in 0, the x's are gone, and I'm left with 7 over 2. And so this is bigger than 3, so it's somewhere up here. So this might help me know where to graph. Okay, I should label that point. Anyway, I told you what it was. You also would notice that it was the parent function, so it's in quadrants 1 and 3, and then we shifted. So we're still here in quadrants 1 and 3. Okay, so looking at this next one, what's the set of values? Well, we had a 0 here. Oh, I am labeling it. This was -7/3 comma 0. Hopefully you can see that. I'm sorry, it feels a little small. But I can do my sign diagram. I have a 0 at -7/3, and I have an asymptote at -2, and my graph was positive, negative, positive. So where am I greater than or equal to 0? I would go from -infinity to -7/3. We want to include that. We don't want to include the asymptote. And so there we go. State the domain. Notice this one was just a lovely transformation of the parent function 1 over x, and so the domain is everything except the vertical asymptote, and the range is everything except the horizontal asymptote. So the domain is -infinity to -2. Pick it up again, -2 to infinity. State the range. -infinity. This was at 3. Okay. And then keep going, find the average rate of change. So when we find the average rate of change, I may or may not do this actual problem for you right now, but the average rate of change is equal to f of 2 minus f of 1 over 2 minus 1. So I would plug in 2 and 1 into this. If I didn't have a calculator, it's a little less pleasant, but I don't feel like doing it. 2 minus 1 is 1 in our denominator. Oh, okay, maybe I'll do this one. I won't do the next. F of 2, plug in 2, I get 6 plus 7, I get 13 over 4. 13 over 4 minus plug in 1, I get 10 over 3. Is that right? Oh, that's annoying. All right, plug in 1, 3 plus 7 is 10, 1 plus 2, yeah. And then if I didn't have a calculator, I'd have to get a common denominator and keep going, and I just don't feel like it. Sorry. Okay, and that's also, it's easy. Okay, I mean, if you had a calculator, it's easy. If you don't, then you could come up with a common denominator if you had to. This same idea, I'll just set up the formula. So there's the average rate of change for those. Okay, so the next one, they want us to talk, we want to practice our limit notation. And so we want to see the limit as x increases without bound, so it goes to infinity, of f of x. Well, so what's happening? Well, we have this lovely picture back here that shows us that we're approaching that asymptote. Likewise, what happens as I approach negative infinity, right? This is decreases without bound of f of x. That would also equal our lovely asymptote. Okay, then we're using limit notation to describe f as x approaches the vertical asymptote from the right, and then here as it approaches from the left. So the limit as x approaches, what was our vertical asymptote? -2. We're approaching -2 from the right, so we put a plus sign of f of x. And what does that equal? Was as we approach this from the right, we were shooting off to positive infinity. The other one, limit as x approaches -2 from the left of f of x. What was it doing? It's coming here. It's going down, down, down. That goes to negative infinity. Okay, then I said find the inverse and sketch it below. Okay, so one way to think through this is to switch our x and y's. X is equal to 3y plus 7 over y plus 2. I could think of this as being a fraction and cross multiply, however you want to do that. I have xy plus 2x equals 3y plus 7. Amelia found a cool way to do this problem also, to find its inverse without doing this. So ask, well, hang on, I'll just finish it. Okay, my brain. I need to get all the y's to one side, all the x's to the other. So I have x, y minus 3y equals -2x plus 7. And I could factor out a y. I need more space. And I get y times x minus 3 is equal to -2x plus 7. Then I can divide -2x plus 7 over x minus 3. Okay, and so here's my graph. You'll notice, I may not fit it on the paper, but that's fine. I have asymptotes when x is equal to 3. I got that from the denominator. I had that they were the same degree, so I divide my leading coefficients. And so I have a y asymptote of y equals -2. So when I graph that, I have an x, 1, 2, 3. Y equals -1, 2. Oh, can you see what I'm doing? Okay, and then I can set the numerator equal to 0. -2x plus 7 equals 0. That'll give me a 0. Subtract, divide. X equals a negative divided by negative is a positive. And so 7 halves is going to be, this is 2 halves, 4 halves, 6 halves. 7 halves is in here somewhere. So we're doing something like this. And then we also can say what happens when I plug in 0. I get a -7/3, which is down here somewhere. Okay. And you'll notice, so we just said we had the point 7 halves, 0, and we had 0, -7/3. Well, notice from back here, I had, compare those, what was x is now y. And what was y, okay, so these two switched, you see that? And then these two switch. And so that's good reinforcement. That helps me know that I did the right thing in finding that equation, or finding that graph. Okay. And then it says here on the, anyway, we finished that, but I didn't label everything, but you should. It says f is invertible, meaning we could find, if we take the inverse of the function f is a function. So give a reason why. We would say every output value of f came from exactly one input value. Okay, that's the language they like when they talk about is it invertible, talk about inputs and outputs. If they ask is it a function, talk about inputs and outputs. Okay, state the domain of the inverse of f. The inverse of f was way back here. The domain would be everything except that vertical asymptote, which was 3. And the range would be everything except the horizontal asymptote. I think it was -2. Let's double check. We had a horizontal asymptote, sure enough, right there. Notice the cool thing with this one. Let's see if I can zoom out a little bit. Can you see the whole page? Not really. Oh yeah, you can. Okay, the domain of f would match the range of the inverse of f, and the range and the domain match right here. So that is pretty snazzy. All right, good luck. Like, subscribe, comment, and go practice.